So in this video, we will be talking about locuses using the argument, format. So this will mean a locus that will be just a line segment, a half line segment on an angle. So let's first talk about the Cartesian derivation of this. So on the Cartesian plane, which we'll just draw out here, we'll draw that out here. Let's say we have a line that follows, let's say, for example, let's have a line that looks like this. Looks like that. And it's on a degree of pi on 4 radians here. It's inclined at pi on 4 radians. So it's a line inclined at pi on 4 radians, going on infinitesimally with a base point here, where it tends to 0, 0. And this is on the Cartesian plane. So, how would you write this as an equation? This would just be y equals x, y equals x. But you could also write it as y equals x tan, let's go back here, x times tan. Where does tan equal 1? Tan to the negative 1 of that should be pi on 4 of pi on 4. This equals the line angle half line with inclined at angle pi on 4. As it tends to 0, 0 here. But yes, so this is how this looks like as a Cartesian derivation. And you could put a limit on this and say, for example, y is greater than or equal to 0. And that's how you could define that, or y is greater than or equal to 0. So how would you write this in complex form? So in complex form, we use a format called arg, or argument, the argument of theta. So, how would you write this? Let's give an example. So, let's say we have a locus, which is defined by z. The locus is defined by z. And let's say that locus is equal to, x plus yi. X plus yi. Now, the tangent, or the inclination of this line, will obviously be equal to tan of y on x. And that's how that's done. So that's what this line would be inclined at. Now, therefore, but since these x and y will only ever be located in one of these quadrants, so like say if we draw this argand plane out with the imaginary axis and your real axis, this xy can only ever be put into one of these 4 quadrants. So this could be all possible values of x. But since it could only be in one of these 4 quadrants, then it's obviously going to be a half line. So that's how that works. So you can write this in complex form. You could write this in complex form as, if you want to do this one, as the argument of z. Z equals pi on 4. Argument of z equals pi on 4. And that would just mean you've got a line going at argument of pi on 4 infinitesimally out in that direction there. As it tends to 0, 0, because it's only going. So the argument is that you can only have line pi on 4, starting from 0, 0, as we haven't had any constraints in here. What you could do is you could adjust this. You could say the argument of z plus 1 minus I. Now what this would look like, or because you would rewrite it like this, as you always do, your argument of z minus something. Argument of z minus negative 1 plus I, I've just changed the signs around there within those brackets, equals pi on 4, pi on 4. And then that would look like, if I go down here, what that would look like is this. Your starting point where it tends to will be at -1 plus I, so I'll be at here. And then moving up in increments of pi on 4. And that's how you would write that. Yes, so that's how you do the locus as an argument showing the inclination of a half line.